everyone. I'm very excited to host Jessen Gibbs, co-founder and CTO of Make It. Today, we would like to discuss what's the journey of developing Make It and the technical and practical applications of Make It. So, very excited to have you on the show.
Yeah, it's a pleasure to be here. I'm excited to chat a little bit about the AI and AX space and hear your questions.
So, can you walk us back at the time when you were exploring the development of this product with your co-founder? What were some brainstorming sessions looked like at that time?
Yeah, absolutely. So one of my co-founders, Stefan, is an architect. He was an architect for quite a few years in Montreal. Um, and he faced a lot of challenges in his day-to-day just with coordinating either communication efforts with his clients across a bunch of different communication channels, and also just streamlining his design flow. So he found he was managing a bunch of different design tools like Revit and Rhino and ArchiCAD and things like that. So we had a discussion about there's kind of these two parallel processes that are done in an architecture job, and we wanted to tie them together somehow, but with focus on one. So we decided to build a web application that manages the collaboration efforts of an architectural project, but with the core technology around automating the schematic design process. And we're really focusing right now on the early phases of kind of the conceptual design, figuring out what those basic parameters are for your project and embedding that in that contextual collaborative space so you can share your design iterations fast and kind of accelerate your process.
Got it. So you're catering the early generative, like conceptual space and using AI to generate various design options. Is that
Yeah,
right?
yeah, yeah, exactly. So we've gone through a bunch of several iterations of how to actually approach that. Um, and it gets quite nuanced. We all know that architecture isn't a very easy to uncover domain. It,
Mhm.
it's a lot of kind of personal challenges and personal design preferences in there. And many architects aren't actually able to communicate kind of why they make certain decisions. So one of our challenges is really digging into the architectural process and understanding what are those kind of decisions and the thought processes behind an architectural design. And right now we're focusing on the residential floor plan. So why does an architect decide to put a room where they do? Why do they decide to have a closet somewhere of a certain size, and how do they consider the light distribution throughout that floor plan? So there's so many different considerations to be made, and it's really been mapping those out in a valuable way. So we need to accommodate those high value constraints first in our generative process, and then start to add further details down the road. So right now we're focusing on that kind of napkin sketch, which allows you to specify what are the primary design constraints here. So what is the square footage of that floor plan that I want to work with? How many bedrooms, how many bathrooms, how many garages do I want? And then we can spit out various different options for that to just kind of kick off your design process, open up the discussions with your client, and then you can take it into your personal environment to enrich that. But what we're working on the technical side is really adding more constraints as time goes on. So starting to consider the context that is around the floor plan itself, and also allowing you to add more details like furniture assets and things like that.
Got it. And from the idea till the minimum viable product, what has been the most technically challenging aspect you have faced?
It's really trying to represent the constraints in such a way that an AI model can learn them. So that we model these constraints in our head seems quite natural. But if you really try to articulate how do you lay out an architectural floor plan, it's difficult to do that succinctly. So it's been a very big data modeling problem. Is how do we actually format these constraints so that the model can learn them independently, but also process them in parallel. And that's why it's a very slow incremental process, because every time we add a new constraint, we have to figure out how to model it properly, make sure it's consistent with the other attributes that we're already considering, and then be able to run that in parallel.
I see. And one of the thing foresee in AEC and architecture compared to other AI industries, like many times the data set is not properly labeled or not in the right format. So if you want to integrate that in the workflow, it's quite a challenge. So what what are some like AI model architecture tricks which you like integrated, which worked well for your product?
It's been kind of a trial and error process for us. So like I said, we've gone through a few iterations with this approach. We started off with a procedural generation approach where we actually tried to pretty much use as little AI as possible, and just do what they generally do. They use this approach for animation films and stuff to make the cities and things like that. So we tried to make kind of a procedural algorithm. We found that it didn't scale well. So it does adhere well to the constraints that you're able to write the code for, but it doesn't scale well and it doesn't deal with ambiguity well. So if you don't have all of the constraints that the system requires, then you can't run it. Our approach after that was using a GAN-based approach. So pretty much is using adversarial training to on ground truth floor plans to kind of start to exhibit similar behaviors from our generator. We found that anything adversarial generally it has a hard time adhering to constraints, and it's not able to. It's kind of a black box, so you don't really understand why it's making decisions that it is, and we need to have a lot of clarity in that sense. And kind of comes down to the problem of scalability again. So a challenge, or I should say, a solution that we kind of found to around that problem is reducing a floor plan down to its most basic representation. And a floor plan is really just a graph. It has these nodes, which are rooms, and these edges, which are adjacencies. So we wanted to break it down to the most simple representation possible so that training a model to understand it isn't that technically difficult. There's no kind of semantics around it. It's quite clear and cut that this type of room is this node type and this adjacency is here. So it's really been formatting a floor plan in such a way that there's no ambiguity about how we need to structure it.
Got it. And so it takes like a graphical input and generates like design options in like numeric format, and you do post processing to show it in like flow plan.
Yeah. I mean, that's pretty close. It's really like it kind of come if we can go. You want to go right back to like the data problem is like some data is mislabeled. So we've used a bit of computer vision stuff to pretty much extract graph representations of existing floor plans. So just kind of getting that basic graph and edge representation. And then because it's a little easier to figure out where the errors are in that, we're able to kind of correct the mislabelings. And we just train on the graph representations. The challenge that we're facing now is how do we make sure that as we accommodate new constraints, we have to make sure those constraints are accommodated in our existing data set as well. So for instance, right now, the nodes in our graphs are just represented using a node type, which is kind of the type of room it is. So whether it's a bedroom, a kitchen, a garage, a living room, and then the X and Y dimensions. So the models get trained on that. And then every time we add a new constraint, whether that's a third dimension, if we want to go into 3D, then we have to make sure we revise our existing data set to accommodate that, retrain, and then build up the constraints in that sense.
I see. And like currently, like it's deployed as a web-based tool.
Yeah. So it's a web-based tool. Or it's a pretty traditional web application architecture. We're using Node and React and everything to kind of house the project. The pipeline goes through pretty much you collect the user inputs on the web interface. Everything gets formatted as a JSON. So the reason we're trying to use a JSON representation is because one, it's easy to parse into a graph structure, and two, we do hope to scale directly into 3D generation. So right now, the constraints you give us, just you'll be provided with a 2D representation of the floor plan. In due time, we're hoping to go or allow you to choose whether you want a 2D representation or a 3D representation. And the JSON formatting for that allows us to kind of scale into different services using 3JS and things like that to open up possibilities.
Interesting. And I was like checking the website. You guys have currently like beta access or like a demo. So what's your roadmap?
Yeah. So we are, as I said, incrementally adding those constraints that users are requesting. Talking to people both on the kind of individual architecture side and the enterprise space to see how we could make this fit into the widest domain possible. right now we're working with some pretty core constraints. In the beta platform, we're just allowing you to specify the total area of the floor plan, the number of bedrooms, number of bathrooms, and garages. So you can just kind of get those basic requirements down for your project and discuss that with your client. What's currently on the roadmap is adding a contextual consideration with that. And this is definitely the most the innovative part of our research is that there's not a lot of space or not a lot of work that's been done in this space. Some people might make the connection that the way we're generating a graph is kind of an autoaggressive approach. So we pretty much, as a user, you provide me a set of rooms that you want in your floor plan, and we incrementally add another room into the floor plan that we're generating for you, and based off of the previous state, predict what the next best position is for the given room. And this is a mechanism that's used for in natural language processing, for text generation, and also in kind of the medical fields for molecule generation, where things are incrementally built up in kind of this autoaggressive approach. So yeah, we're hoping to pretty much allow you to build this basic graph for the architectural considerations themselves, like the actual floor plan, but then also while we're generating that, consider this provided area, because we all know that floor plans have to be realized in a physical space. So whether that's a plot of land or the envelope that you want that floor plan to be built in, allow users to specify that, because it's a very big part of the process. So you can specify the dimensions of wherever you want your floor plan to go, and in the generative process, we'll make sure we consider that generative zone in producing designs.
Got it. And I'm curious to know, like, there's so many things going on in AI world. Every day there's new models. Like, how do you keep up to date and like make decisions? What's best?
I mean, it's a bit of a team effort. So we all just kind of, whether it's scrolling through the web, looking at different postings and stuff, or we all have kind of our own resources. We have also, we're in partnerships with a few research organizations. So we've just partnered with Mila and a couple other organizations to help us conduct internal research. So there are lots of different sources, whether it's the Mila blog or the Mila newsletter, individual postings from different academic institutions. One of my favorite resources is Semantic Scholar. You can pretty much use a semantic search to look at the most recent publications that are released in your space. And it is just reading a lot of academic literature.
Got it. And are you guys like doing evaluation of design generation? Like the point I'm interested to know, like how do you evaluate a solution which is like subjectively good objectively?
Yeah, the subjective objective problem of architecture is a major challenge. So that's where we try to, like, our goal isn't to remove the architect by any means. We're really trying to enhance them and almost allow them to use architecture as a design fabric, if you will, in the early stages. So we do rely on the feedback from the expert to some extent, where you can provide kind of what your general requirements are, and we'll give you what that objective floor plan is, right? So it'll follow the physical rules and spatial orientations that a floor plan should do, and it should also follow the general distribution of rooms across the plot of land. But if there's small nuances that maybe you as an architect could add your own style to, or your client wants to add their own style to, we afford a human in the loop mechanism. So what we give you right off the bat isn't final. That's not, we're not kind of leaving you in the dark there. So we'll provide you with this initial generative output of the floor plan, and you can review it with your client, get feedback, and then adjust it accordingly and run that. It'll kind of converge on the ideal design. And the idea is that we don't really want to take over the entire workflow. We're really just trying to accelerate that point so that you can get into the more construction documentation phase faster. And kind of take on more projects, and just to kind of accelerate the entire design process as a whole.
Got it. If you had unlimited time and resources, is there any feature or testing you wish you could do?
In terms of a feature, I mean, resources, I'd say our vision would be a lovely thing to accomplish. And we kind of say we'd like to make it to get the home, your dream home, or to get whatever building you want. It should be as easy as having a conversation, because conversation comes quite naturally, and we all know what we want in our minds when we're like, oh, I want my dream house, I want it to be this shape and these materials and stuff. But when it comes down to it, there's so many different levels that you need to go through to actually accomplish that. And it's unfortunate that a lot of us have this dream house, this kind of dream environment that we want to find ourselves into. But it always comes down to being able to access the expert that is able to do that. And that might be, it's very difficult for most people to do that. So we want to kind of democratize the architectural process in that sense. So it's not just left up to those people that their entire lives to developing the skills and understanding to actually make this physical structure. It comes down to just being able to talk and have a conversation about what you want and express that using natural language, so that as you're speaking, and this kind of comes, it's related to like Siri and Google Home and these things. You can say like, hey Siri, or hey Maquette, this is going to be my dream home. I have a family with 4 kids and I have a dog. I like these kind of designs. And as you're having that conversation, whether it's a VR experience or on platform or on a web interface, the actual design is being spun up in real time. So having a natural language element added on top of this generative design process is really our vision for it. And that's obviously going to require a lot of resources and a lot of time, but we will make it there in incremental steps.
That's amazing. Like I was talking to Theodore and the guest on like about AI trends, and he was also suggesting like natural language in like architectural design space exploration is quite the future we are moving towards. And are there like I'm curious to know your thoughts on like models and developments from OpenAI, like DALI, Clip, and what are your thoughts on those kind of models integration in architecture?
Yeah, absolutely. I mean, I have access to the OpenAI beta and stuff, so I play around with it every day. I love their language stuff, and Dolly too is a phenomenal tool. We've actually explored using Dolly just for a style transfer mechanism. So when we want to go from kind of this basic conceptual design to a more detailed schematic design, and even possibly into 3D, we've explored using Dolly. Unfortunately, we require massive overhaul and kind of fine-tuning the model to accomplish that. But in a more related sense, we have actually worked with language models to pretty much try and construct like an architectural grammar around how you describe a floor plan and things. And we've used these kind of text-based mechanisms to explore it. Unfortunately, given the resources we have right now, it wasn't a suitable approach. But I do think it's, for anyone working in the AI space, whether it's language or AI, the work that OpenAI is doing is fantastic, and similar for other organizations like DeepMind and Google. But these applications are going to be unlocking a whole level of creative expression, I think, in these spaces.
Mm-hmm. And so in AEC, like there are like pretty well-known generative algorithms, and I haven't seen like a lot more companies spinning off in this AI generative space. Like, so what are the things like you're doing like which makes you like stand out and successful in this approach?
I think it does come down to our core technology. As far as we've surveyed, a lot of people are taking a more traditional approach, and as far like our understanding is that's a GAN-based approach, because the most of the easy to access information on floor plan designs and stuff is in an image format, and GANs are kind of the primary model that would work in the image space. We've diverged more into a graph-based problem. And that's leaning on the literature that I referred to previously, is with this molecule generation. So we're kind of a hybrid of this kind of autoregressive approach to building things incrementally applied to a constrained graph generation problem. And we've done quite well to pretty much get ourselves up to speed with the research that exists in constrained graph generation. Unfortunately, it's not a very well-researched space, so we are reaching the limits of that, or we've reached the limits of that quite early in our research. And our new approach, or kind of our latest research problem now, is actually localizing the graphs. So as I said, there's this kind of contextual component or spatial component to the floor plans that isn't captured in a molecule, or you don't actually, to have a valid molecule, all you have to consider is the physical properties that are between the atoms in that molecule. In our case, we can meet the requirements for the floor plan, but if that floor plan can't be realized in any plot of land, then it's useless. So we have to make sure we have a consideration for that, and deriving actual positional values relative to a build context is very difficult, and it hasn't been done in the graph-based approach yet. So that's kind of what I think makes us stand out, is essentially our technical approach.
Got it. And do you plan to have like a API based access to your tool in future if someone wants to integrate in their workflow?
Yeah, absolutely. So the planning right now is, I believe it'll be the first of many different products we roll out. I think we'll be building a whole suite of different services, but everything is going to be built around this core generative technology that we're building, and we definitely like to move into an API based model. And this is because I think the technology we're building can scale well beyond just not even just residential architecture and just enterprise architecture, but into entirely new domains. We're trying to make it agnostic to the type of objects and relationships we're working with, because graphs are so abstract. As long as the attributes that are assigned to the molecules, or sorry, the attributes that are assigned to the nodes in the floor plan are consistent with the attributes that are being used in a different domain, we can apply ourselves to that. So, for instance, the model that we're using to generate floor plans can be exactly the same model that we use to generate different furniture distributions within a room itself. So as long as you can specify the dimensions and the type of thing and there's a general pattern between the relations of different entities you're working with, we can apply that to across domains. And that's where we see this API scaling into, is you might not just be an architect building a residential home, you might be a city planner building a city, and you have to orient actual buildings in a physical space. So you can kind of, depending on how micro or macro you want to go, you can apply this API to whatever problem you want.
Interesting. We have a question from Harry. Your thoughts on generative adversarial networks?
I think they're a black box, so it's really difficult to get insight on how they're actually learning and why they're exhibiting the behaviors they are. I think they're fantastic because you don't need a lot of information to get decent behavior out of them. The challenge is that it comes down to, if you have a lot of really well labeled data, you can get great behavior out of it. But if you ever want to scale into an added feature or a different domain, you have to rebuild the system entirely. So it is pretty fixed and non-dynamic in that sense. But GANs are still part of our pipeline, and I think they always will be. And I do see a lot of room for growth on them as well. The adversarial space is a really interesting area, but frankly, they're just so poorly understood at this point in time that for our use case, it doesn't make sense.
Mm-hmm. And is it possible for you to talk about like what are like various graph based machine learning models out there, and like which one is good for this design space problem? Like I'm talking like graph reinforcement learning combination, or graph RL, or like CNN or something. A lot of variations in.
Yeah, I mean, it comes down to the domain that you're working in. So if you're working with really feature rich nodes, then there's certain architectures are going to be good. We're working with recurrent neural networks right now, just because they're relatively scalable. It is also a question of the size of the graphs that you're working with. So some graphs or RNNs work very high node counts, so they're more efficient in the sense that if you have thousands and thousands of nodes, they can process those much more efficiently, much faster. GNNs are good at working with a smaller amount of nodes, and that you can get more expressivity out of them. But if you give them thousands of nodes, they'll kind of, the behavior will not be exactly what you want. So in our case right now with the residential space, where like a floor plan generally doesn't have more than 12 or 14 rooms in it. So a more fitting architecture would be the GNN, but because literature right now is developed on RNN architectures, we're leaning into that right now, and with future iterations, we'll likely converge on a more fitting model for that. But I think it really varies on what information is being represented in the graph and the scale at which you want to represent that.
Got it. Have you had an incident about like an outlier in the computation and how you dealt with that?
Yeah, I mean, I think it always points back to a data problem. I think most people working in AI will tell you that it always kind of comes down to just data science, and if the data isn't labeled properly, or if you don't have a good enough distribution, then you get some very funky behaviors. We often find that some of the graphs that we extract from the ground truth data, there may or may not be an edge missing or that. So instead of having a fully connected graph, you have these kind of two disjoint sets, and that sometimes shows up in the output that we get, where we, instead of getting a floor plan, we have these kind of like weird disjoint rooms all over the place. And it really comes down to like making sure that when you do pre-process this data and get the data sets ready for training and everything, you have to be very thorough in the way that it's being represented, and also have really a well-distributed training set, in the sense that you're getting a good coverage for your problem, and then also for the testing set too. So whether you split your data sets well, so that you're not just testing on part of your distribution, you really getting good coverage as well. And the question of coverage versus precision is another problem with architecture, because there's, once again, so many constraints and considerations that have to go into the problem. We could be super precise and give you super highly accurate room placements or super highly accurate adjacencies, such that any architect would be like, yeah, that's it, that's right. But we might not get the room types right, or something like that, or the scale or the room sizes might be off. Versus coverage, where we can kind of cover a plethora of constraints, but do them not quite to as well a degree as we could if we just attacked one. And that's an internal discussion that we can always have, is do we kind of continue to improve on one constraint, or do we add another constraint and kind of incrementally improve the behavior across the entire set?
Gotcha. And you were part of Techstars 21. Can you walk us through like how was that experience? What are the things involved in that?
Yeah, Techstars was fantastic. It's really about the community in my mind. I think getting in with a tight network of like-minded people is one of the best things you can do for pursuing anything you care about. And we were just surrounded by 12 companies that were doing the exact same thing as us, having the exact same problems as us, and just being able to kind of do what you and I are doing now, is kind of do these deep dives into what we're working on, what our problems are, and getting the varying perspectives is super valuable. And the management there was fantastic. They had some really good input on the business side of things and the technical side of things. But for me, it was mainly about the connections and kind of connecting with other CTOs and technical folks.
Got it. And how do you see like this transition from like software engineering to architecture? There's a whole new domain out here.
Can you elaborate on that a bit?
Like you mentioned briefly about the complexity of architecture domain. So I was curious, like what are some things you found like very different? Because like coincidentally, like software architecture and our architecture design have some terminology which is common, but like are there any like some assumptions or confusion point of view from our domain?
I think it's the general interconnectedness of decisions you have to make in architecture. Is if you change a single parameter in the design you're making, that has to be propagated throughout hundreds of other considerations you've made. With traditional software development, if you make a nice modular system, you can make a change to a whole part or a whole module of that system. You have to worry about how that propagates through. I think it's really just how connect and kind of personal that system is that you're developing. And that's why making that procedural approach, in my mind, doesn't scale well, especially if you want to end up being cross-domain. such that if you want to rewrite a single function, you have to make sure that you accommodate those changes throughout the entire system as a whole.
Got it. I have a rapid fire section for you, and you have like only 10 to 15 seconds to answer it. So
Okay.
gotta keep it brief. Okay. Which city is in your travel bucket list?
Cities are my travel bucket list. Um, I'd like to go to Tokyo for sure. I'll be going to Copenhagen soon, so I'm excited to see the clean city up there. I've never been to that space of the world. Um, I don't know. I'm more of a nature guy, frankly. Ironically, I'm in architecture, but I like nature, so that's all you can get out of me.
I see. Any technical or business book which made a big impact in your life?
Um, I find business books are generally pretty surface level, no matter how deep they seem to make themselves. I found that the human use of human beings is a really interesting book. It's by Herbert Weiner. He interesting perspective on information theory and kind of the entropy in systems. Systems thinking and graph thinking, I think, is a really valuable approach to anyone getting into the technical space.
Mhm. Your role model?
Role model, um, probably my brother. He's 5 years older than me, also in the startup space. Always kind of been an inspiration, and we connect very well on most perspectives.
Is he a software engineer?
He's more of a business guy gone technical. So he did more of a business approach and then gradually became more technical as he went through his jobs.
Mhm. Your favorite movie?
Ooh, interesting. Honestly, I don't know. I don't watch a lot of TV. Um, Probably like Lion King or some Disney Pixar movie.
I see. What is your piece of advice for people who are interested in this AI in design space?
Um, don't overthink it, I guess. Like just it's more intuitive, I think, than people make it out to be. I think, especially with AI, there's so much ego associated with it that people want to feel good because they're working with AI, and they throw this kind of complex language around it. It's more than it's made out to be. It's really just kind of, whether it's architecture or AI, I think anyone is capable of getting into that and understanding it and working with it effectively. Just don't let the egos in the space scare you off.
Got it. And like, is there anything which we didn't cover in this interview and you would like to share?
I mean, maybe a little bit about our vision and kind of why. I know I've said we're trying to democratize the architectural process. But I think one of our main challenges, and I think a lot of folks that are trying to bring progressive technology into the AX space will face this, is that it is a legacy domain, and there's many interconnected, very complex parts of this space, that it's just inherently hard to get into. It's really hard for anyone who, if you aren't going to train for years in one of the verticals that are in this domain, you're going to have a really hard time getting into it. And I think it's intentionally designed. For some reason, it's intentionally designed that way. The knowledge systems around architecture and engineering and construction are just very personal and very human based, and I think that's great. But in terms of efficiency and actually allowing this space to become more impactful than it is today, we need to make those knowledge systems accessible to the lay people, to everyone. Like, I don't understand. I'm working in this space from a technical perspective, and I still barely understand it. And I think we all have so much to learn. And I really just want to make these knowledge systems more accessible to people in their daily lives. I know this is a internal perspective that we have for sure, is that architecture is kind of an ever-present art form in our lives, and it really has a deep impact on who we are at any given moment. And it's unfortunate that it's left up to a handful of individuals to construct our living spaces. And I want to give people, I think Maquette as a whole wants to give people the power to construct spaces that they want to be in, and kind of have power over that art form.
Yeah, that's a great vision. I have one more question. You gotta answer like bullish or bearish. So metaverse,
Bullish.
blockchain,
Bullish.
generative design.
Very bullish.
Yeah, obviously you work in that. Awesome, Jason. It was a great time hosting you, and thanks a lot for sharing all the technical insights. It was great seeing how you're developing your product at Make It, and I really look forward what you guys are coming, and good luck in this journey.
Awesome. Thanks so much, man. It was a pleasure chatting.
Yeah. Have a nice rest of your day. Bye.
Bye.